Yeah, thanks a lot for having me here. So, so I'll do my regular talk, but I'll switch to whatever you're interested in. So if you're not going to follow the regular thing, eventually we'll go other places, which is fun. So just keep asking, just to, or whatever. It doesn't have to be Hazelcast related or JCache related or caching related. It could be NoSQL or big data. So Hazelcast. So we know Java hash map, right? So it's non-thread safe. If you want to share the map across multiple threads, you do this. And if you want to share the map across multiple JVMs, you do. You create a Hazelcast instance, and then you get a map from Hazelcast, and then you do put get. Now this data, all these entries are going to be shared across multiple JVMs. So let's say you have a web application, you're building a shopping cart or an application that has a session for user. Instead of putting the sessions into local Tomcats or application servers session store, you can put it into distributed map. That way, every JVM will have the session. Even if you lose the node, session will be available on other nodes. So, Hazelcast, I started Hazelcast 7 years ago as a distributed data structures project. We started with the distributed map. We had queue, atomic long, all the other data types. So let me do a quick demo first, and then make sure we all understand what it is, and then start. Dig deeper. So this is the zip. When you unzip Hazelcast, you're going to see zip. That's so small, right? Even for me, it's small. All right, so how do we make this big?
Change it to scale.
Click on scale.
Okay.
There you
And maybe, yeah, big enough, right? Okay. So in the lib directory, you're going to see all the Hazelcast jars. So Hazelcast all contains all the other jars. That's the only jar you need. Just pick that jar, put it to your classbed, you're done. There's no dependency on any other external library. The Hazelcast jar is the server jar. Hazelcast client is the client library. If you want to connect to a cluster, server cluster, Hibernate, Hazelcast Cloud is the AWS discovery library. So if you're running Hazelcast on Amazon EC2, Hazelcast nodes will find each other if you use the Hazelcast Cloud jar file. So if you're using Hibernate, you can use Hazelcast as a second level caching solution. And if you're using J2EE, and if you want to have Hazelcast participate in J2EE transaction, then you need the JCA connector. If you're using Spring, definitely you have the Spring jar. And if you have, let's say you have a web application already written, and you want to cluster the session without doing anything else, you don't want to change the code, you just want to cluster automatically, you have to use this web manager jar and Hazelcast, and you add a filter, web filter in the web XML. Hazelcast will automatically cluster the session for you, so you don't have to do anything. You don't change the profile, you just change the web XML, and Hazelcast will cluster your HTTP sessions for you. Of course, you can do it programmatically with the Hazelcast map or JCache API. So, by the way, so as I said, this jar is the only jar you need. It contains all the other jars. So that just work with this single jar to make life easy for you. And we have management center here so this is a web application, WAR5. So it can run on any, of course, Tomcat, WebLogic, any Java web server, or it can be you can start the management center from a script like this. So it's an executable WAR file actually. So the demo contains the demo application that I built to demo Hazelcast. Let's see what it does first. It's a very simple application. It's a command line application. It says Java, use this library and run this console app. That's what it does. So I'm just going to do that. sh, console sh. So this guy, let me make it big. Okay, so now it says like, hey, there's only one member in the cluster, it's me, and there's a command line application, as I say, if I do m.put, 1 and Seattle, so it's a map.put basically, right? So it's just nothing fancy, and I get 1, I get the value. But the good thing is that if I run the same application on another JVM in the same network, it doesn't have to be the same box, of course, somewhere in the network. So the second node will discover the first node, and they will form the cluster of 2 nodes. So now we have 2-member cluster. So if I say, hey, m.get from here, I get the value from the second JVM. So this is currently embedded Hazelcast. The jar is part of the application, right? So this is a server runs inside the application. So let's say you have a web application and you put Hazelcast jar into the application and you call Hazelcast get map, and the server starts inside the application. You can also do, of course, client server. That means you can use the client API to connect to the cluster, just like in the database world with a driver, you connect it to a server, or NoSQL world has the same stuff, right? So, but I'm just saying, like, Hazelcast can be embedded into the application. So that's one of the benefits. It's just a single jar that's very embeddable. So let's visualize this cluster. I'm just gonna run this end center, cd into management center, sh start management center. All right. So this is running Jada right now. Jada running that WAR file. So admin, no, connect to my dev. All right, so you can do this exact same thing, just like the way I did. There's nothing fancy here. So you recognize my maps, default map, and I see my entry here. So this one is saying, hey, so this node, second node, contains one entry here, and this entry is actually as a backup on the other node. So that makes sense. We're just fine. Okay, so I'll put more entries with many, like 1,000. So I'll see that. So now 1001. So this guy owns this many. This guy owns this many, and with backups on the other node. So that's good. So that means if I shut down one of the JVMs, I won't lose the data because I have another backup copy. Hazelcast by default has one backup. You can configure to have multiple, more, or 0. You can configure to have asynchronous or synchronous backup, of course, but by default we will have one synchronous backup. Synchronous backup means when the map output returns, it guarantees that the backup is taken care of. So, but let's see what happens if I start another node in the network. Let's see, it's here. Of course, we expect to have third guy coming in, and then we're going to see data is rebalanced again. The data that you're seeing is not really like stopping the world and getting the numbers. So you can see funky numbers. Sometimes that's fine because we're not stopping the world and just telling you what the count is. It's okay. No, you will eventually see 1001 here. So as you can see, now almost like equal balance, which is good. But there's no like, hey, there's no 330 anywhere here. The reason is that it's not like one node is the backup of the other. It's more like these entries are backed up right here, equally, like 160 here, 170 there, kind of. So the reason is that when if I lose the first one, I don't have to. These backup entries are going to be owned by those guys, and I don't have to rebalance again because it's already balanced. But of course, we have to take care of the missing backup. But we don't have to rush for that. We can slowly take the backups. Okay, so it's a distributed map, yes, but we added more stuff like distributed locks. If I lock an entry here, so again some Java map, but we extended the API. So now this JVM owns a lock on the key 1 for this map, and I can actually see that here. It's right here. So this guy owns an entry that is actually locked. So it shows me that. And if I try to update, let me show this a little here. Okay. Put 1 and New York. I won't be able to update because there's a lock on this entry. But this is now like frozen. But if I do unlock from here, as soon as I hit enter, the other one will receive. So now m.get1, of course, will be. So distributed map with locking capability. So we also added things like, and also lock will disappear from here because there's no lock here anymore. Okay, we also added listeners, like we can listen for all the updates happening for that map. So this guy is listening right now. So nobody else is listening, but this guy is listening for all the updates happening in this map. If I do put 2 and Istanbul, I'm original from Istanbul, Turkey. So it says, hey, this key is added by this member, and the value is Istanbul. So, okay, I think this, yeah.
Question for you. So, with the locking, what would happen if that the JVM that holds the lock goes away?
Okay.
And I mean, in one case, it might be maybe that the other nodes notice that it's gone away. In another case, maybe it disappears kind of silently, or there's no notification that it went away.
Okay.
How does it get resolved?
All right. So let's. So now I lock the entry here. So there's a lock on this. So this is the lock owner JVM. And let's say this guy is trying to update with Palo Alto, and because we have an owner, this cannot continue. And the question is, what if this owner of the lock dies, right?
Yes,
that's the thing.
correct.
So what do we expect to happen? So owner dies, and so if you don't release the lock, this guy will be waiting forever. So that means this guy should release the lock if the owner dies. And let's try this. And before we try and try a little bit, because it's a demo, right? So let's see if so I'll try try to hit enter and see, yes, it went through. So that means the update happened. So if I do m.get1, get the value. So yeah, so so we also saw that, so we still have 1002, so we killed one of the nodes, and we didn't lose any entry. We still have 1002. Yes.
You want to go ahead?
Oh, so,
Okay.
how much of this monitoring information is exposed through JMX?
I think mostly, not everything, but there's an API for those.
Okay.
There's a per map you can get all these statistics via Hazelcast API. So all the throughput information, they're like average latency and all that stuff. So you can mostly with JMX, but all visible or available through API. You have that question too?
Yeah, so the lock key itself is actually a member of the map, right?
The lock.
You said lock one?
Yeah.
So you're locking on the value one. So if you're creating your own lock object, and you say lock on the object, some string, it's going to put it into a map that holds on to it. And then when you release the lock, that object stays in the map. Is there any?
Oh, yeah.
Because I've had issues
Yeah.
where we create locks and they just persist over,
Right. So
and they don't go away.
right. So if you use the locking interface, Java, so Hazelcast get lock and you pass a string as the key.
Right.
That lock object is actually a distributed object, and it has to be destroyed when you're done. Like because the intention is that you're going to be using that lock for a long time, and when you're done, you destroy it. And if you don't destroy it, yes, the key will be stuck.
So can you?
If you want that behavior, that like whenever you're done, whenever you unlock, you don't want to like do the garbage collection. You want Hazelcast to garbage collect entry. Then I would suggest you have a map, like locks map, and then use and then do locks map dot lock, and then pass the key.
Like have a lock key pool or something like that.
Say it again.
Have a pool of lock keys.
Yes, or it doesn't have to be a pool of. I'm just saying, don't use the lock interface. Just use a map, distributed map, and lock a key, because whenever you unlock, if there's no value for that key, Hazelcast will auto garbage collect that entry, which is what you want. So whenever you unlock, you don't want that key to stay around, right?
Yeah. But you want to allow another VM or another thread to use that same key later on.
Of course,
Yeah.
always. You can do it anytime, but anytime you unlock and then the entry has no value, Hazelcast will garbage collect that, which is what you want. So don't use the lock interface. Use a map and use a lock API in this map.
And that'll work on.
Yes.
That'll block other. So yeah, one.
It will act and behave exactly the same,
Okay.
and it will give you what you want, which is auto garbage collect. Yes.
Yeah, so what you're doing is governing the threads, right? So it runs in like a NoSQL environment as well, or you essentially attach your process to the thread, is what this is, right?
So
or is it
we're assuming
JVC
that, yeah, okay. So right now, this is embedded Hazelcast, right? So it's part of the application, and application threads are locking things, and that particular JVM thread is the owner of the lock in the entire cluster. So it could have been that you're calling the API from a client, not the server. Right now it says like a server, right? So it's part of the server, it's embedded server. Let's say you're using the C++, C# or Java client, and you're doing the same similar stuff like map.lock. So in this case, this client, this particular client, and that particular thread is the owner of the lock. So that means whoever is calling the lock, whichever thread and whichever process, so that process and that thread is the owner of the lock. So it could be a C++ process, it could be a Java process, you don't care. That process plus that thread that's calling that API is the owner of the lock.
But for example, in the case of, this is a classic question, obviously, in the case where you avoided a deadlock because you were able to update, right?
Right.
You also, if you're in the middle of, for example, a NoSQL document, right, you've generated an atomistic violation. And how do you retract that transaction or something? Is there some signal that gets sent out to?
Okay, so just like in any any locking situation, or like regular Java locking or Hazelcast locking or any locking, you can of course get into deadlocks and all that stuff if you don't follow the rules of the deadlock, right? So it's the same things will apply. When it comes to like how do you manage the like concurrency access to the updates, this is a little different because when you're doing a map.put, you don't really have to lock anything. You just can say just map.put. This put operation is atomic already, so it's just there is no distributed lock involved in this operation, and it's an update, and we don't even use distributed lock for that. So, but if you want a transactional behavior like you want to start a transaction, you want to do stuff, and then you commit, then you have to start Hazelcast transaction first, do all that stuff with the Hazelcast transaction, and in this case, yes, we will get the proper lock for the update for the entry that you're trying to change. But is it recommended? Of course, if there's a way to run away from transactions, please do. And there are better ways of updating an entry, and we'll get to that. So, so in short, all updates like map.put, map.replace, map.set, all that stuff is actually atomic. You don't need to lock first and then do this stuff. But if you, let's say your business case requires that you get the lock first so that no one touches that entry while you're doing something, then you do the locking. So, and we have a use case for that, and I'll walk you through that example already. So I have a good example for that. So wait a little bit. Okay, so I killed this one, right? So I'll start this again. I love having 3 JVMs. So this is a distributed data structures project. It's not only a distributed map. So the distributed queue is another very, very popular data structure. So let's say, you need to, like some of the JVMs are creating jobs, and some of the other JVMs are consuming the jobs and processing jobs, let's say. And you normally, in this setup, you normally you deploy an ActiveMQ or like JMS server, and then you coordinate everything with that. Normally that's the case. And what we're saying, if you're already running Hazelcast cluster, if you're already distributed data and all that stuff, 99% of the time you won't need any external caching, messaging system. You can do all that stuff with Hazelcast. Like, let's say this queue, we have a queue, and this guy is trying to take something to process, and this guy is also trying to take something to process, and they're waiting right now because there's nothing in the queue, and we're gonna add something. We're gonna offer or put in some task into the queue. Of course, only one of them will take and process. This JVM took it and just now processing, and the other one is still waiting. And we're going to offer another one, task 2, and now the second JVM took it and just processing that stuff. So any JVM can offer into the queue, and any JVM can take out of the queue. It's just Java blocking queue that's distributed also with backups, right? So the queue will also have synchronous or asynchronous backups. and it will use regular Java blocking API. So topic is another one, just pops up messaging. I'm not going to demo this. It just we'll dive into the technical details a little bit and then answer more questions. So it's an open source Apache, single jar, no dependency, Maven friendly. Just add the dependency, you're good to go. So how do we distribute the data? Like you have, let's say, 10 node and 10 million entries. Each node will own 1 million of it, and maybe another 1 million for the backup. So, but how do we navigate? What happens when you do map.put with key and value? What happens? So Hazelcast contains like by default 271, but of course you can set it to 5,000 if you want to. Partitions. These are virtual buckets that the keys will be falling into. So each key will fall into one of these partitions, and here's how it actually calculated. We take a key, hash it, and mod with the partition count, which is static. You don't change it after you set it, and it will give you the partition ID for that key always, right? So that means for a given key, the partition ID is always the same. And then we just, and each node will say, all right, who owns this partition? So there's a partition ownership table that every node knows. It will say, oh, this partition is owned by this guy, and the location is routed to that node. So when you do a map.put, you take the key, hash it, and then mod with the partition count. We figure out the partition ID, and then we say, who owns this partition ID? This guy, and then we route the put operation to the owner. So the operation will always go to the owner of the partition or owner of the key. And oldest member in the cluster will try to balance the cluster and reassign the ownership of the partitions. So Hazelcast is peer-to-peer clustering. There's no like a master node or like manager nodes or anything like that. Everybody is equal. Every node is equal. Everybody has to do very similar stuff, but just the oldest member, the first member in the cluster, will have to do some extra stuff, like accepting new members to join the cluster, or deciding on whether the node is healthy or part of the cluster or not, or make the assignments, like who owns this partition, right? Balance the cluster and all that stuff. So, eventually oldest member will die, and the second oldest member will become the oldest member. And it goes on like that. So just, all right, so we saw the embedded Hazelcast. It's this JVM. This is your application. Uses Java API, and Hazelcast node runs inside the JVM, and they talk to each other like that, right? And this is embedded, and the client server is just like any NoSQL or database stuff. You have your data server cluster. And then you use clients like Java client or .NET or C++ client to connect to the cluster. Each one of them has its goods and bads. Of course, embedded is so convenient. It's part of the application. You run the application. You don't have to think about setting a cluster or maintaining the cluster separately. It's so easy when it comes to deployment, but it's problematic when it comes to isolation of the problems, right? Like something goes wrong with the JVM or application, and then you say like, okay, is it because of the Hazelcast? Is it because of my application? We're sharing the same JVM, same memory and all that stuff. Who's causing the out of memory issue and all that? Like isolation is such a big problem. And also as you're redeploying the application, right, with the new code, now you're restarting the server node together with that, right? So upgrades are not really that good. But there are so many cases where you don't do the updates as often, and you care about the simple deployments more than anything else. In those cases, embedded is the way to go. But if let's say you want to have a clear separation of the data storage and the application, and also you want to be able to deploy your application as many times as you like during the day or during the week, then client server is definitely the way to go. And also, of course, if you want to scale your application separately from your data cluster, that's also another benefit, right? That's a good separation. It says native memory there. Normally, I mean, Hazelcast will store all your entries in Java JVM heap. That means if you store 10 gig per JVM, you'll run into garbage collection issues. So if you want to have like big caches, like hundreds of gigabytes or terabytes of caches, then you should consider using native memory for off-heap storage to avoid long GC pauses. So this is how you start. So this you say, hey, Hazelcast new Hazelcast instance. This will be create a server, and so that you have right now with this code you have 2 servers and 1 client, and you can run this in the same JVM. This could be a part of your JUnit test. So it's in a JUnit test you can start 5-node cluster and test everything in one JUnit test, and we do that, by the way. We do a lot. And servers can be part of the same cluster, can be part of this different clusters, and you can play with any configuration you like. And as you can see, both server and client uses the same interface, Hazelcast instance. That means you can start the application in an embedded mode. You can say, all right, I don't want to deal with client server, I'll start embedded, put Hazelcast server inside the application, use Hazelcast instance API, and then later on you said, like, no, it's not working out. I'm just going to separate the server from the client. I'm just going to separate Hazelcast from the application and go to client server mode. Your code will stay the same. Only part has to change is the way you create the instance. That's it. On the application, you just change that line, you're done. Because interfaces are going to be exactly the same. The code samples. So the Hazelcast thread safe, so you don't have to like do locking and then do put setting stuff. So there's no, entire API is thread safe. So we saw that you can start many instances in the same JVM. And we rely on serialization. So that means either the object itself, when you do a map.put or q.offer, the things that you're putting into Hazelcast, the objects has to be serializable, or like implement serializable or data serializable, whatever, some serialization API, or there has to be a serializer provided externally that will serialize that stuff. So serialization is the biggest cost in clustering. Is the biggest cost. It's not network. If you're thinking the network is the bottleneck, no, it's not. Serialization is by far the biggest cost. So optimize serialization as much as you can. Try serialization frameworks like Cryo, or use Hazelcast interfaces like data serializable or portable object in Hazelcast, or use protobuf, anything you like, but just try to optimize serialization. Try to stay away from regular Java serialization because it's the biggest cost. Network is pretty fast. 1 gigabit, like now usually people do have 10 gigabit. It's crazy fast. You cannot even properly process what's coming from the pipe. Usually network is super fast, but the path to the network is pretty slow. Because you're going to go through serialization and then you're going to hit a couple of synchronization points like queues and stuff, and go hit the socket, and the socket has its own synchronized blocks and all that stuff. Like as soon as you hit the network interface, I mean, you lost a lot of time already. So the path to the network is slow, not the network itself. So don't blame the network first, blame the path itself, and the serialization is the biggest one in that path. So you can use the cluster interface to get the members or listen for the membership changes. You saw this API, right? So you use use atomic operations like proof absent. It's very important because you're doing distributed operation right now, right? It's costlier than normal Java operation. So that means checking things and putting things is more expensive than normal. So if there's a way to do atomically all this expensive stuff, do it. Definitely go with the atomic operations. Multi-map is a new data structure. It's a one-key multi-value. When you do a map again, you get a collection back, and you can remove a particular item from that key. Queue, distributed queue, we already talked about it. It's your Java util concurrent blocking queue. It works exactly the same. So only the way you create the queue is different, and the API is exactly the same. We talked about this. This is if you use this, that lock object is a distributed object and has to be maintained and it has to be destroyed separately. But if you use a map, then this lock, so this as soon as you unlock, if there's no value attached to this value, this entry will be garbage collected automatically, which is kind of nice. Yeah, if this is not working for you, definitely come up with like locks map and use the lock API here. Topic, just like JMS topic, multi-listener, multi-publisher, and you like this code will compile on Monday, everything's fine. You say, give me a topic, and then you say, I'm going to be listening for this, and I'll publish a message. And on message, you'll receive the stuff. It's super simple. It's crazy fast too. If you don't want total ordering. Yes. So of course, we're not saying that we're replacing the whole messaging system. It's far from it. We're just saying that there are so many things that, like messaging systems like JMS and all that stuff, they usually do provide things like persistent listeners or persistent messages and all that stuff. Our persistence is not as durable as disk. We do have a copy on another JVM, but it's not on the disk, right? So, what we know is like 90% of the time, what we provide will be good enough for the application. So if it is not, then you go and see if the JMS fixes your issue. So JMS is good. There's nothing wrong with that. So events, we talked about events, so you can listen for map events. Transactions. So let's say you want to be able to do something like queue.pull and process that stuff and put something into a map, and then commit, or something went wrong, you roll back, right? And it could be two-phase or a single-phase commit. Of course, do I recommend transactions? No. You do it if you really have to, because it is slow. You won't be happy with the performance and things. but let's say performance is secondary and you care about the consistency more than everything else, then transaction is the way to go. So this thing will require two-phase commit by default, because you're talking about two different sources. This queue can be on one of the nodes, and this key can be on another node. That means you're talking to two different nodes in a transaction. That's also called two different resources. And if you really want to be transactionally safe, you have to go with two-phase commit to make sure that we manage two different resources in a transaction correctly. Durability of this transaction is, of course, still in memory. So part of the transaction, we have the transaction log that is copied to another node in the cluster. So in case, just in case the transaction node dies, we have a copy of the transaction on somewhere else that can complete the transaction after it's repaired. So again, durability. So is it two-phase commit? Yes. What's the durability level? Is it disk? No. It's a in-memory copy onto some other node. So of course you can set more than one copy if you really want to be getting more security. Okay, execute service. Java tool execute a service but distributed. So you're going to have a callable, that callable will run somewhere in the cluster. So that's the promise. So you say, Hazelcast, give me an executor service similar to Java tool concurrent executor service, but now if you submit a task, this task will be running somewhere in the network, in the cluster. And you can say, hey, run the task on this particular member. You can say, run the task on this particular key, meaning go to the owner of the key and run there because my data is there. Or you can say, run everywhere and give me the results. So it's a good service. So you have customers map, let's say, and customer object contains all these properties, and you say, hey, I wanna find all the active customers with age less than 30. And of course, you can iterate the map and then find, but it's ugly, it's bad. Of course, one easy way would be you send an executor service to iterate or query local data and combine the results. But it's not. I mean, it feels good or sounds good, but it's not right because we have to understand that the Hazelcast is dynamic cluster. While you're doing this, it is possible that another node will be joining the cluster, and some of the nodes or some of the entries are going to be migrating to the new node. And you might be running that calculation during that period, right? That means you can double count or miscount. So it's not really like that easy. So for that reason, we built the API internally to avoid all these corner cases. So you can say map that values and just pass a predicate active and less than or equal to 30. You can also use indexes, of course. So there's another second parameter there that says, hey, at the index, but it doesn't have to be sorted. This has to be sorted because I'll use range query. So that's what it means. Of course, you have the index once, and then you start querying. Okay, this is our Hazelcast architecture. So all the way down, networking, we listen from a socket, and then we do have cluster management, so that we accept the nodes, and we have nodes working together. Then we have partition management. That means, by the way, like regardless of the data structure you're using, partition management is like data structure agnostic. It just says who owns which partition, how do I migrate one partition to the other, without knowing any of the data structures running on top. So it's very generic. That also means you can come up with your own data structures tomorrow and use exactly that library, the internal library, and you can, we'll take care of the migration of your data structure. You don't have to deal with that. And there's a node engine on top that takes care of threading, like eventing, like when you're listening for an update on a map or a queue, right? When you do wait notify, meaning queue.take is a wait. Or invocation, when you do map.put, it's a distributed invocation. And that's all taken care of in that layer. And we have a low-level services API for these. So that means this is the API that we have to use, or you have to use, if you want to build your own data structure. So all these data structures are built using this low-level services API. That's why you can have your user-defined. Let's say tomorrow you want to build a distributed actor system. I don't know, like you're inspired by Apache and you want to have distributed actors, or you need a hierarchical lock and you want to build that data structure yourself. So you have to use this API, just like we use this API and build your own data structures. Yes, so on top, so we added what? Map, queue, security service, atomic long, right? Topic, map reduce, entry process, we'll talk about this. Aggregations, which is actually using map reduce also. And all the concurrent API or JCache API, so all that. So, and then the client. We have now a client network protocol, which is open source, which is protocol is very well defined. You can build your own client if you like. Yes, I think. So the blues are the like a pink. I think this is pink kind of color, right? I'm
Salmon.
color blind a little bit. Yeah. So that is.
It looks terracotta to me.
What is it?
I'm joking. I said it looks terracotta to me.
Okay, yeah.
That was a bad joke.
That's Sorry. So the blues are the enterprise stuff, like security, event replication, ALFI, all that stuff, or C, C++, C# stuff. Okay, so that's the architecture. JCache. So there's a new spec called JCache, finalized. Years after, like I think it's
6
12
years or something like that?
way more than that. I
Oh,
started
wow.
like 2003-ish.
That long?
So that's that long, yeah. So finalized. So it's part of Java. So you'll see containers, Java servers, and implementing that. So everybody will be using this interface from now on for caching in Java. And Hazelcast was, of course, the implementation of JCache. It's pretty much like Java Map, but it supports the events, computation, integration. So these are the implementations, or these are the guys who are planning to implement. So there's quite a bit. So it's nice to have options. So, of course, Java EE8 will have it. Spring already does. MuleSoft and WSO2 and all the other guys.
Sure.
You will.
And Tommy's in it.
Tommy will. Okay.
Supports it.
Will support that. Yes. So what is? So it looks like this. Like there will be a cache provider, like Hazelcast provider or coherence provider, whatever, right? And then you'll create cache managers that will create the caches. So that's pretty much what it is, and it will look like this. Caching, get the cache provider, and then provider will give you the manager that will create the caches for you. annotations, like you can, this is beautiful. Spring already had has something like that for a long time. You can cache the result of the invocation. You can say cache the result of this call, and underlying container will do the job. Yes. So it does have cache loader. So let's say you have a database somewhere else and you want to cache some of the data, and you define a cache loader that goes to your database and load the entry if the entry is missing. Cache writer will write the content of the cache to your database. It could be NoSQL or relational. Doesn't matter really. It's because we give you the entry. You don't care how you write it, and we ask to load it when we don't have it. So that's the deal. So you implement that, and there will be implementations available like for JPA, or Mongo, Cassandra, that you don't have to write, like it's already written for you. But if there isn't, then you just have to implement those interfaces, really. So the idea here is that you have apps, and if you have a Hazelcast kind of distributed cache that can cache all the data sources and also write to your data sources. Maybe one map will be writing to relational database, but another map is backed by MongoDB, or another map is backed by Elasticsearch for indexing. So you're still talking to middlemen that will then route the right data to the right data store eventually. So when you're writing, writes can be synchronous or asynchronous. It could be like it's part of the put, meaning synchronous, or asynchronous, meaning every X seconds, the records will be flushed to the underlying data store. So of course, the synchronous one is more reliable because it's part of the operation, and you know if it failed or not. But the asynchronous scales amazingly well because, and latency-wise, it's better because you don't wait for the write, and all the dir records will be flushed in one shot in a batch operation, which is something our databases love. Yes, still not done though. It's there's still a lot to do. People are talking about asynchronous API for the JCache, addiction and query mechanism. Transactions are not there. So but people, I mean, it's getting there. So all the good thing about the JCache is that I probably been to like hundreds of companies, and they all have their own way of caching stuff. They usually have their own internal caching solutions, even distributed solutions all over the place. So this guy is just saying, hey, all right, use whatever you want to use or build whatever you want to build, but at least have a common interface that developer don't have to learn, that can be used by any developer anytime without learning anything new. So specs are good. Of course limiting, but good. Okay, so let's say this is a scenario that I think this is the best part of the presentation to me because it gives you a lot more. So far we learned about this stuff like the API and all that stuff, but it doesn't give you like how to think about this, like how do you approach this distributed world. So let's say we have a customer object and it contains orders, and what you want to do is you want to remove one order from that customer. So usually what you would do is like you get the map for the customers, and then let's say business requires that you lock the entry because you don't want any change on the entry while you're doing this stuff. Let's say you don't have to, but let's say you do. So in this case, you say, I'm going to lock the customer ID, I'll get the value, and then I'll update my object, I'll put it back because I changed it. Because what you got is not the reference, right? It's a copy of the thing. If you don't put it back, Hazelcast or distributed cache doesn't know anything about it. So you have to put it back. So one of the differences between distributed map and regular Java map, right? Regular Java map will go with the reference, but distributed maps or caches will go with the copy. So you put it back and you online. Of course, you have to do it like with try finally, but forget it. So this is good, but this is bad. Really, I mean, easy, understandable, looks okay, but it's very bad. Why? Because you're doing 1, 2, 3, 4 distributed operations plus the backups. It's like 7. Not 8 because the get doesn't have any backup operation, right? So 7 operation. So it could be like 7 distributed calls to just get this done. It's crazy, right? So how can we optimize this? Any
The
suggestions?
executor? What is it? Using it the executor?
Yeah, right. So you can, but let's say we have a callable to do all that stuff, and then do what? How do we make sure that it goes to the right node?
Throwing in the customer
By
ID,
key,
right?
Yeah,
The customer
right.
ID.
So we're just going to route the executor server or callable to the customer ID. So that's, so order deletion task is callable, but it is also partition aware, which says like, hey, Hazelcast, use this ID to route the call, right? So, and now I'm just going to take only customer ID and order ID and send it to the owner, and it will be taken care of there. And now this call will be running on the owner of the owner node that of this customer object, which is nice because lock is like local call, but there is a backup operation. Of course, we don't fix that issue yet. The second problem, so this get will be local, which is super good. Put will be local and backup will be remote. Unlock will be local and backup will be remote, right? But please from 7 to 3, and together with the call is like 4. So pretty good. So and even better, you don't have to bring the entire customer object back to the caller, do the change and put it back into the cluster, right? So the object could be really big. Imagine a game object that contains so many attributes, so like a lot of nested objects and everything. Could be super, super expensive. So at least we also save from that. So instead of that, we just send 2 fields. Perfect. We did most of the operations local. Pretty good. Yeah, but still not that good because we could have done better. And the answer is entry processor. It's part of the JCache spec too. The entry processor says, I'll run your code on the entry with an implicit lock. That means you can get rid of the locks. And also, I'll do the backup operation the way you like. I don't have to copy the whole value again. So this is this. So right now, of course, with the executor service, you have to create this task and submit, right? So with the entry processor, you say, hey, the lead order is an entry processor, and it is also a backup processor too for us. The process will do, Hazelcast will pass you the entry, so there's no like get, right? We give you that already. And then you have the customers, and and also Hazelcast gives you the implicit lock. That means while you're executing this, it's guaranteed that like no one is touching the customer, and it's even guaranteeing that this entry is not even migrating somewhere else. Even if there's like a new node joining, this won't migrate until this is complete. So it's great, like it gives you way more guarantees. Okay, so it will process this and look at the backup process also. The backup says this is also a backup operation. So that means the same code will run on the backup and it will only change, it will only pass this little object there. So it's just like passing way smaller object around, and it's giving you implicit lock on the entry. So while you're doing all that change, like you can do way more, of course. Here you can do go to database, blah 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 blah. If the object contains this and that, like, or do any calculation on the object. But while you're doing this, the entry belongs to you, and no one will be touching your object. So this is the perfect way of using Hazelcast or any JCache implementation. Definitely go with the enterprise. So yes.
So what happens if this process has to touch another object? And so now I've got the primary and the backup running at the same time.
Right. Yeah. Okay. So your second part wasn't really entirely related. So you also said, what if backup and the owner?
So you said it's going to run this task on both the owner of the cache entry and the backup.
Right.
So what if the process involves
multiple
going to the order object and marking it as deleted at the end of the process?
Right. So you can just say entry.set null. Is that what you?
Yeah, but the backup is running at the same time, and it's going out and trying to find this order that might be on another partition and update it. So I've got two processes running, trying to.
Then it's okay. For this entry, there's no way that for this entry there's another process happening somewhere else. Because every the entry processor or any even put or even get will go to the owner node, and owner node will be processing this, and synchronization is going to be handled on that node. So there's no way while you're playing with this customer object, there is another node that's working on the same customer object. There's no way for that, because you targeted the owner. There's one owner, and entries there, and you have the implicit log. There's no copy of this thing somewhere else.
Right, but what if I'm trying to update the order object, not the customer? Not two people updating
Oh,
the
you're
same
saying
customer?
two different maps?
Sort of like a cascade
Right.
delete.
Right, so I go and I say this customer is no longer associated with this order. I ran that on the machine that the customer is on. But now I have to go to the orderer and flag that order as this order will not be fulfilled. So now I've got,
so like two different maps then, are
Yeah.
they?
yeah.
Okay. Right, so in this case, yes. As you can see, the entry processor is actually by name, like it says like entry processor. That means one entry will be affected by this processor. So here the logic is that, so just like the document approach, we want all related objects to be in one big object. So if you have, if customer and orders should be orders of this customer, orders for this customer should be inside this customer object, just like a document
So
object
like in Mongo.
approach. So just like in MongoDB world, but does it have to be like that? No. So you can have two separate maps, one customers and one orders. In this case, though, you have to use data affinity to make sure that the customers and the orders for this customer are on the same node, right? So because we go by ID, customer ID and order ID. They have to be somehow related. It's called, so for this case, order key has to be partition aware and pointing to the customer. So there's an example for that. I'll show you after the presentation. But still, it's problematic. So that means with the data affinity, it's possible to collocate related objects, customer and orders. But can we give you the same guarantee? Like you process customer map and related entries in the orders map in an implicit lock and with the processor? No, not yet. But we're working on something called partition processor. So that gives you that access. Like from the partition, you can get customer's map, find your customer, and then go to your orders map and find your orders in one process. And you can atomically change both in one shot. So that requires partition processor. So edge processor is not good enough for that. Yes.
It seems this delete order class here is going to actually modify the entry itself.
Correct.
And then run again to modify its backup.
Yes.
Right? Is it possible that you can end up in a situation where the process on the primary entry succeeds, but on the backup it throws an exception? Or something happens on the backup,
It
but
is possible. Yeah, yeah.
it doesn't, and now you have the same object is out of sync between its copy and its backup.
Correct.
And what happens at that point?
Right. So if you freeze the world and if you get a view on both the owner and the backup, you'll definitely see like they're not entirely matching because you don't stop the world and make sure that like atomically both are getting updated. So that means that view is going to be always like that regardless, right? Like even everything is going fine, every node is healthy, it's still going to be the case.
Mm-hmm.
But from the perspective of the caller, right, when you do execute or when you do a put, similar problem will happen with a put, right? When you do a put, maybe put happened on the owner, but the backup failed, or owner just did it while backup was doing it, owner just died. So all these situations can happen, right? So from the caller's perspective, hey, I want this operation to be happening on the server, on the owner, and backup, and I get notification from the backup that it is done. So as soon as I receive it, I'm done. I'm good. Otherwise, I'll check if the backup server has the version that I have. So it is possible that like there's a disconnect between the server, the owner, and the backup, and it will happen. By the way, it could be seconds of disconnection and all that stuff, and they will get out of sync. Hazelcast works in a way that you remember the partitions? Each partition has its own version. So when we send an update to this other side, to the backup, we also pass the version of the server. And we say, hey, backup, this is a new update for you, but the version on the server is this. Is this matching with yours? If it is not, then the server backup can say, looks like I'm out of sync with the owner. So in this case, he doesn't know how far he's lost, right? Like how many updates the backup lost. So that's why backup will say, I need the entire partition right now, because I don't know how much I lost. So that also brings you the question of like, if the partition is very big, like this can be expensive, right? So that's why when you start your cluster, before you do any of that stuff, you do like a sizing exercise. Like you say, what should be the size of my cluster? How many nodes should I have? Or what should be the JVM and how many entries am I going to have? Is it going to be 100 million or is it going to be 10 million? What is the size? And if each entry is this big, what should be the partition count for this? Because you want each partition to be small enough to migrate fast and pull up the backup fast if I'm out of sync. So that's why the partition count that we talked about is important. And if you have like hundreds of millions of entries or hundreds of gigabyte cache, you definitely need way more than 271. Probably need like a couple of thousand partition. That way, partition is small enough to move fast.
I also meant like the flexibility in the API here, because you're actually allowing the caller here, this serializable task or this serializable processor, to do something to the main entry and do something different in the backup.
That's
And this will actually create the same version of both, but they're actually not the same data at that point.
They don't have to do the same, right? Like usually you go to the owner and the owner node probably will update the stuff and send an email to somebody else and do some database call. Backup doesn't have to do any of that stuff. Backup just have to update the entry, right? So that's why there's a separation of like, give me the backup operation. So at the end of the thing, we just say, you know what, during that processing, I just updated these two fields, and I just need these two fields to be updated only. Here is a backup processor for you. Just go and run this thing on the backup. You don't run this thing on the. You can say that. So that's why we have this separate. Yes. So now you have this, and instead of doing execute service, you say, give me the map. Here's the entry processor. Execute the entry processor on the customer ID. That's what you do, and then you get a result back. That's super simple. So thanks so much for listening. It was a long talk.
Yeah.
So if we have a complex data model and a lot of processing requires different objects to, let's say customer and order, they have different partition key. So there's no perfect word that they will collocate out.
Oh, there is, and I just didn't I used to have this slide for that. But all right, the order key. So that we have to achieve collocation of the related stuff, right? So make sure that they're on the same node. So for this to happen, first, Hazelcast partitions by the key, as we talked about, right?
Yeah.
So because order ID is different than the customer ID, they can be on totally different nodes. So how do we force the order ID to be on the same node as the customer ID? So you have to come up with a custom order ID, order key, not order ID, order key object. And order key can say, I'll write it here. So is it?
Yeah.
Okay. Order key class implements partition aware. Okay, and it contains customer ID and order ID separately, and that's like what is it called? Two different
Composite key.
All right, so the get partition key returns what? Of course, returns customer ID. So what you're saying, this is going to be your key for the orders map. So you're gonna create a custom key for the orders, and it will contain both customer ID and the order ID. But when it comes to routing, what you're saying with the partition aware, what you're saying, hey Hazelcast, look at this key. As you can see, it is partition aware. So when it comes to routing, call this method to get the key, which is customer ID. But that way, your customer entry and all the orders related to this customer will be collocated on the same node. So then, of course, you can do what? You can send an entry, not entry processor this time, but executor service targeting the customer ID. And the executor service can say, all right, give me customer object. Good, I get the customer, which is local, right? And then now give me, so from the customer object, give me the order IDs, because I'll get to the orders from you. And then inside this executor service or callable, you get to the orders map and get the orders separately. Because you know that they're collocated, you know that they're on the same node.
Yeah, I understand this scenario, but the thing is, let's say I need to pull in all the products associated with this order, and then you won't have a optimal dominating partitioning key, because the product can be shared by many customers and many orders.
Yeah,
Then it
okay,
becomes
so
a
then
complicated
it's
scenario.
many
Yeah.
stuff.
So
Right.
is there like a best
No,
practice?
I think so we know that when you go from relational world to distributed world,
Yeah.
you have to balance the normalization stuff, right? So you say, all right, this part is going to be highly normalized, but this part,
Yeah.
I will reuse some of the stuff, or maybe I'll come up with a complex object that contains stuff together, right? So like a document approach.
Okay.
So I don't think there's like a single solution for any of that stuff. I think so I think there's a single golden rule, at least for me, when you're thinking about all that stuff. You don't say like that means you're going to eventually have to design the model in a not that normalized way. You know that already. But how do you do that then? Like, how do you balance how normalized you should be, or which part should be not normalized or normalized, right? So I think you look at the overall system. You say, this part is my biggest pain, right? You say like, if I achieve throughput for this particular task, I don't care about the rest, right? Or these three things is the most significant. The rest is like whatever. So you have to be able to say, you don't go by how things are related, but you go by like the use case. And you say, for my use case, what's more important for me? And then you normalize or you optimize that part first. Yes, so you don't, yes. So that also requires the full understanding of the entire system. You don't just say, okay, this is the data model, here's how I will model the things. You have to understand the whole thing. Hazelcast will store the values in binary format by default. That means when you do a put, we serialize your object into byte array. We move the byte array to another server, the owner's node, and store it as byte array. When you need it back, we just send you the byte array back, right? So, and you look at your system and you say, you know what? There are maps that I only care for like super fast reading. So I care. I don't have byte array ready to go. So your storage type format should be byte array, because you know that map is significant for that. But for another map, you can say, I'm going to do a lot of entry processing. I don't want to have the object in byte array format and deserialize back to object and serialize back to byte array all the time. That's stupid. Like, why would you want to do that? So you just say, for this map, my storage type will be object, not byte array. So in this case, Hazelcast will store your values as Java objects, as values, because you're going to be doing a lot of updates on the object. So what I'm trying to say is like, you have to know the system. You have to know the pain or the biggest pain points in the system, and you have to update the design for those pain points. Not like, all right, what's the optimal way of modeling this thing? So, yes.
What strategy would you recommend for updating application servers using Hazelcast without data loss?
Okay. Are they embedded?
Yes.
Okay.
They're
Okay.
embedded.
So that's okay. It's a common problem. So you're saying, so now I have embedded Hazelcast running in my application. I have 10 of these, and I have a new code base. I'm just gonna do a rolling upgrade, or and how do I make sure that I don't lose data while I'm doing that?
Correct.
So, so let's say there was a way to say, okay, you shut down first, and you started with the new code base, and then join the cluster, everything's fine, but you shut down the second one before you take the backups and you lost data, right? So someone has to say it's safe to shut down, right? And there's an API for that.
Okay.
So just like it became like it just sounded like there's an app for that. So in the Hazelcast.get partition service do have an API that says like, is it safe, or is safe.
Okay. So we have
if it's safe, then shut down. So that means Hazelcast knows that if every backup is taken, it's safe to shut down one node. Hopefully, we'll bring that into a management center so that you don't have to like programmatically call something to say to know if it is safe or not.
Okay. Thank you.
Yes.
Do we handle any hot partitions? Because
Yeah.
especially
So what happens if it's a stock market application and Apple is just going crazy, and one of the nodes will be hot, rest will be sleeping? So the short answer, no. For us, everybody is equal. We don't, and we don't go by the key. So that means I cannot say, oh, this key will be on this node alone. And so, like, I think I got this question enough that I'll just do it sometime. But there's no solution yet because we go by partition ID, and we don't even know what's inside that partition. We don't know if the keys are hot or not. But I feel the pain.
What's the overhead for the backup process under heavy load on both the backup and the primary node?
What's the?
I mean, heavy load is the heavy puts from both nodes, and on both the backup and the primary node, the owner node.
Okay, but
And what's the overhead for the backup to complete?
What's the overhead? Like I'm just trying to.
Yeah, I try to see like in terms of like latency or the network, the resource consumption.
Okay. Okay, so I'll tell you what's happening, and then you calculate the overhead, because it's hard to like come up with numbers for like overhead thing.
Yeah.
So the caller will do a put, goes to the owner does the operation, and returns the response back immediately. There's no blocking on the server.
Okay. Yeah, that part of it.
Yes, and then in the meantime, the owner will say, okay, I'll fire up the backup to the backup server, right? It knows who the backup is actually.
Mm-hmm.
So, and now the owner sends two messages. One to the caller saying that I'm done, wait for the backup. And also to the backup saying that I'm done, do the backup. And send back the result, and send back your acknowledgement to the caller. And then the caller is waiting, gets the message from the owner, and then now it's waiting for backup node to send an acknowledgement. right? So everything is actually happening asynchronously. There's no no one other than the caller is actually blocked. No one, none. So that means you can, with single flag, you can say, hey, for this map, I just want asynchronous backup. What you're saying for the API is like, do exactly the same thing, but the caller don't wait for the backup acknowledgement. So the overhead is actually exactly the same. It is if it is synchronous or asynchronous. It's just a copy of the entry is sent to the other node. That's the overhead.
Yeah, I think I didn't ask it. I think a better question would be exactly the communication mechanism when you do the backup, peer-to-peer.
Yes.
So I tried to know that like the transporting, the communication layer, how they notify each other, and how does the object get serialized? Well, exactly what you described earlier, that the path to the network between the two nodes.
Yeah. So
because I think our application might be very sensitive to the cost of this backup. If it's per put or it can be a batch backup.
oh, got it. Okay, it's per put. It's not batch.
Okay.
And everything is so. Hazelcast can use multicast for the discovery first, but after discovery, everything is TCP/IP. Everything is socket connection. So it's then peer-to-peer unicast, and the backups are not sent in a batch way. So every put will be a single backup operation. Yes.
And it can't if somehow I get so far behind that I've done 3 puts to the same object, it can't figure out that the first 2
Correct, but okay.
are bad.
Okay,
and
here's the
just
thing.
jump to
Here's the thing.
last one.
When the connection is healthy, it will never. What you're saying will never happen. The guy will always receive everything in the same order. Why? Because always the owner is sending, and it's always sending in this in a serial way, and then the guy is just receiving one by one. There's no there is no missing order if the connection is healthy. The order will get broken only if the connection is somehow broken or
Different
owner changes, right? Like owner changed to somebody else, and during that time maybe I missed something. So other than that, there's no way that on a healthy connection, because it's not like randomly sending from multiple threads. Single thread is sending every update for that key one after the other. Actually, for the entire partition, one after the other. The entire partition updates are like serialized. So there's when the connection is healthy, there is no way I'll have incorrect version one after the other. Yes. Yes.
When we're talking about like rolling restarts or having the server be able to either the Hazelcast is going to go upgraded, so we have a server and it's running 3.5.1 and we're going to run 3.5.2 or some other version that is later, or if it's embedded and you're going to restart your own app.
Yeah.
Is there a way for the application to, or for the client to say that evict all the table entries out of this node because this node is going to come down instead of waiting for safe and then safe to come down? Like to say reject any, like transfer ownership out for all the records that you have and move them all out and evict them.
Right. Yeah. You're. This is when I mentioned management center doing all that stuff. The way we would have done is the way you're describing. So you just pick the guy, say, remove all your partitions or migrate to somebody else. Now your node active, everything is fine, but you don't own anything.
Yep.
And then we shut you down after you're completely out of partitions.
Mm-hmm.
So that's how we would do if we do it from the management center. Or it's some API or some tool that will do this. And I think that's the right way of thinking. So just empty the whole node and then shut down.
Because I'm wondering of the timing sequence between saying is safe and you get a true is safe, and you start to shut down, but then it's not safe right as you're taking it down
Correct.
because something
It's
is happening.
completely true, and that's the craziness of the distributed system, right? Like, there's no like a distributed clock. Is it safe? Yeah, okay. But even in the case of single JVM, that's also not true, right? You just say, even like a current map, you get a value. You know what? This is the value that you read. Doesn't mean that that's the value anymore. Yeah. It's,
About the native memory,
yes.
how does it improve things? It's like I just avoid the garbage collection happening, or
Right. So normally, if you store 10 gig or more, even less, like 8 gig, it will start from 8 gig about. The JVM will have a hard time dealing with the garbage collection if you're in a lot of updates and stuff. So with the off heap or HD memory, so 3 gig JVM heap can manage 300 gig off heap. That's so that and that space 300 gig is not known to the JVM. It's entirely managed by Hazelcast, running inside that 3 gig heap. So for JVM, life is so good. 3 gig, nothing wrong. There's not much garbage, so life is good. But so that also means Hazelcast will create this huge space, and just like in C++ or C world malloc, it's going to be like a Java malloc, right? Like we're going to manage all the segmentation and everything, or fragmentation and all that stuff. So from the caller's perspective, yes, is it better than or faster than heap? No, if you're able to go with the heap size, right? Let's say 4 gig heap size is all you need, and heap is faster to point to. But because after some point, like 8 gig, your JVM will not be able to perform well anyways, right? There's no way, or like storing 50 gig on a JVM and not you don't feel any GC stuff.
Yeah, my bigger concern is how you get termination notification from objects dying. Like if the Java object died, you release the memory, right?
Oh yeah. So this is not like a general purpose off-heap stuff. It's specifically designed for Hazelcast data structures.
Okay.
Right, so, and we know exactly when your key is created and when it is terminated, right? So there's no mystery. I don't have to do like, oh, should I mark what's being used or not? We're not trying to beat a JVM garbage collection algorithm by any means.
Okay.
They're doing an amazing job over there. So whatever they have is great. What we're saying is like, I know how my data structures are built. I can do better job when it comes to managing the memory. So it's not like a general purpose garbage collection or memory management. Same true for the serialization, right? Java serialization is pretty good because it's trying to cover all the corner cases that you can do as a developer. So is it optimized? No, it's just correct. It's just trying to be correct, right? It's not trying to be the best serialization ever.
Yeah.
But you can definitely say, I don't want you to serialize because I know my objects way better. I mean, way better that I can control the whole thing, and I can serialize, deserialize way faster than Java serialization. Same concept. It's Hazelcast specific data structure storage. Yes.
Say we want to scale up our application massively, how concerned should we be about the traffic from rebalancing? Is there a way to throttle?
I think the rebalancing, okay. So if you do a lot of like ups and downs, of course, then there's something even, something more wrong. I mean,
Right.
We talked about like embedded versus client server, right?
Sure.
So it looks like embedded is not good for you because you're doing a lot of ups and downs, right? Restarts. So
Right.
you better separate them, and you can now start the server restart server as many times as you like. So of course, any restart will disrupt the cluster, right?
Right.
I have to rebalance stuff and re-own the old stuff. So that's a mess. So consider moving to client-server architecture if this is the case. But after that, I don't think you should be worried much because, especially adding nodes is a no-brainer, right? Because you add the nodes, and you don't even have to add like one by one or 5 at a time. It doesn't really matter much for Hazelcast.
Okay.
So the migrations, but which one do we prefer? We prefer that you start 5 nodes at a time, like more, not one by one. You don't, because you start, rebalance, and you start another one, rebalance again.
Yep.
Why? Like if you start 5 and rebalance in one shot. So when you're losing the node, again, I explained the way backups are taken. We try to do our best to not disrupt the cluster, but it will get destruction a little bit because we have to take the backups and everything. So there will be some. When the node is going down, you'll see some. So I think the worst case is not really these. I think the clusters like that, especially in Java world, even without Java world, partial failures are the worst possible things. Like zombie node, having one JVM having a hard time with the GC, or one kernel is panicking, or one guy is unplugged the cable. Like there's some failure that's not really complete failure, it's partial. So detecting that failure will cause more problem than anything else to me. So how do you avoid those? First, less number of nodes is way better than more. So the smaller the cluster, the better. Always, not the other way around. I don't believe like, oh yeah, we have to massively scale. All right, so then you get into all the network partitioning issues, all the stupidity. I mean, if there's no way, of course, there's no way you do it. But if there's a way to like go with a 10 node with 100 gig memory, it's better than having 100 node with 10 gig memory. So, right.
So from an operational perspective, you mentioned that you used multicast for discovery, and I saw that when you're starting up. So you're on a flat network. Can you set up like startup switches and things like that to isolate different environments? So you don't end up with just like one global Hazelcast network or something like that.
Can you?
Does that make sense?
So if you give me an example, like just.
So if you want 3 environments or something like that, say dev, stage and performance or something like that. If you're using multicast discovery, it's a flat network.
Right.
I'll just look at one massive peer-to-peer network. Can you isolate that in some way, or do you have to depend on network segmentation to do that?
Or you can just change the multicast address.
Okay.
We use a username and password.
Yeah, that's still though, like it will still communicate to the other guys, and other guys will say, I don't care about you.
They won't join them.
Or TCP/IP, go with TCP/IP.
Okay, so you can set
Definitely TCP/IP is like way cleaner and more controlled, but it's annoying because you have to know the IPs and all that stuff.
Okay.
And always go with the IP, not the host names. I don't like host names.
DNS is awesome.
Yeah.
Do you see Hazelcast as a replacement to NoSQL databases like Mongo, or a partner?
Not really, because we're all in memory. We want to stay in memory. we will have persistence to persist the whole memory to disk and restart again before hot restart. We're not trying to be database, we just want to be resilient memory.
Do you have any advice on warming up cache?
Oh, yeah.
If I'm fetching it all out of the database or whatever.
Right. Okay. So
Also,
usually,
that's part of what persistence is, instantly while the cache.
if you're warming from the disk, yes.
Yeah.
But if you're warming from an external database, then you can use MapLoader. MapLoader will is probably better because the way we should be doing is in parallel, right? Like each node should be doing their own partitions and loading separately. So MapLoader will do that. Yes. All right. It was too long. Thank you so much.
No, that's perfect. Thank you. So that was